Hello everyone. Today I suddenly decided to practice touch typing. So I watched some video online and I got a recommendation on a website called keybr.com. So that's the one I'm using right now. So the goal is to do. I tried it. I actually did a 30-minute today. I feel like 30 minutes is a bit too long. So 20 minutes probably is a better goal. So I'll do like a 20-minute practice. I think so far, and I just started, I think my left hand handling E, A, R, T, all those are pretty good. But on the right hand, I have a very bad habit. I am using my middle finger to type L, which is supposed to be my ring finger. Okay, and then that is causing a lot of trouble. So the ring finger should be L, and the middle finger should be K and I. Right, so KIM are the middle finger. L, O, and well, you can say the less sign. That should be the ring finger, and like L, O, smaller, and then P. Right, P is the little finger. P, what's this one? Semicolon, and larger than. Right, P semicolon larger than should be the pinky, and index finger should be J. What's beneath J? N. Yeah, J, N, and U. Right, J, U, and N. That should be this. And of course we'll have F, F, T. Yeah, F, T, V. It's the index finger of the right, and then D, D, R. DRC, right? DRC. Actually, C I'm also using. Oh wait, hold a second. C should also be. So the index finger should be responsible for more. Actually, I'm not sure. I'm gonna pull it up. Okay, I'm gonna pull it up and then just take a look. I think I got it wrong. Actually, I shouldn't do this. Why'd you go to my discount? I did go to my account, right? That doesn't make any sense. Yeah. Alright, anyway, what I need to go to is practice. Oh, I don't need this. I want to see. Yeah, here we go. So J U M, right? J U M is index finger. F V R, and then TGB. So the index finger will move like one row inside, right? We'll move one row inside, and I type the space with my thumb, and look at this. The responsibility of the pinky is ridiculous, all the way to backspace. So we need to extend to backspace. And are you telling me the the brackets also has to be the little finger and the P? Oh, P is hard. But yeah, P is hard. Okay, J U M H Y N, and then we have K I and a smaller than, right? Ki and smaller. This is smaller than. Ki smaller than. Ring finger is L09. So we do have to go up, go down. That's right. R. That's right. N, A, L should be this. Right, all, later, tall, IT, title, tell, late, relate, lit, lie, real, ladder, till, lie, tall, line, learn, tall, tail, lie, tail, ball, Letter. Yeah, so it's okay. I mean, mainly it's the practice is on the left hand side. Like my pinky on A is pretty good. I'm pretty good with A. This is the left pinky, but the right pinky at A position is actually the semicolon, right? It's a semicolon. So P is gonna be like this, 0 gonna be like this. Oh, I'm not supposed to type. I would just. Oh, you do this way. Hold on. So you're supposed to be 6, 7, 8, 9. 6, 7, 8, 9. Okay. 6, 7, 8, 9. Y, H, N. No. It's J, U, 7. Right? The 7, U, J. So if you want to type, you just move your finger up. Move your finger up, then we'll hit P. Going here is here. Going down, that's M, M. This, and this. Right? Same thing here. We found F, right? Then we R. This is 4. 1, 2, 3, 4. Q, W, E, R. S, D, F, G. And go down X, 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 C, V. X, X, C, V. Z, X, C, V. Well, it'll take practice. It'll take a lot of practice, actually. But it's kind of a new thing I want to do. Because I feel like, at the moment, the thing that's slowing me down in terms of Vim motion and everything is I need to see the keyboard, right? I cannot just touch type, and that is definitely slowing me down. Definitely. All right, let's do this. Squares of a sorted array. And also, because I spent like more than half an hour on the other, so I'm trying to just do half an hour on this. Just speed it up. All right, squares of a sorted array. Given an array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing array. So we need to square it and we need to sort, right? Square each element and sorting a new array is very trivial. Could you find an ON solution using a different approach? Yeah. So what we're trying to do is we need to find an ON approach. ON approach. ON approach. What we can do is, dear me, ON. Well, if you start from negative, right, then those will go somewhere else. How do we handle the negatives? So we go negative, negative, negative. We can do that, and then we go to the positive, and then what? Wow, ON solution. How do you do ON on this? Well, Okay, there is an ON because we can do, what's that called? Merge sort, right? We can use a merge sort, and that's ON. I mean, do you want to do merge sort? Can. I mean, why not? Yeah, we get the two arrays, right? And then we do a merge sort. It feels, I don't know. I don't know, man. Feels. Yeah, we can create the same length, right? And then as we put it in, will be this. We'll put it in, and then this one will be this, and we will return a list. We'll have to create. Yeah, this is gonna be in Java, so let's see what we're gonna return. We'll return an int. Okay, we'll return an int, and then we can just produce both, right? And then we move into the new one. Oh, I don't need to. I do not need to. Ah, I see. That will be an interesting design. All right, let's try this. Yeah. Yeah, this is not right. It's supposed to be the number 2 should be my ring finger. Right? The 2 should be ring finger. The J, no. So ESC should be my pinky. 14. It should be pinky and 4, right? 14. And V is also this. And this should be, oh, yeah, that's wrong. Okay, so 51. So V. Wait, I kept pressing. Oh, if you move down. So it should be the C is your middle finger. Man, this is tough. This is very tough. Okay, let's try it again. 38. Alright, this requires a lot of practice. Because my typing was... Okay, so there are 2 ways for me to approach it. Okay, there are 2 ways. Either I just let my bad habit go. Just keep my bad habit. Don't change it. It's just the way I type. It's just the way I type. I move around a lot. Because I am, like, when moving around a lot, I am at 70, above 70. Or you change and then when to make it right. I don't know. It's hard to say what would be the best way. Because I just move around. I move around a lot. All I want to do is make sure that, okay, so we can do something like use the pinky more, right? Use the pinky more, that's for sure. Use the pinky more. Whether it's my ring finger, I don't use my ring finger too much, that's for sure, on the right hand side, so I should use more of that. Anyway, so what I need to do is, like, I can, like this is right? I smaller than dot, what's a dot? Dot's supposed to be, and L is here, right? And this, no, this, yes, it's the pinky. plus. What's plus? Plus go up. Plus should be pinky. And plus plus. It's hard. It's very hard. It will slow me down tremendously, but maybe I should. You know, just hover your fingers on this, right? Just hover it. Remember, always going we do slowly. We do slowly. I want to do it the right way. I wanted to do it the right way. Okay, so what we want to do? So we have I, and we just say nums. N should be here. U. Where's U? U is also here. M's. Ah, it's really it's bothering me. All right, it's really bothering me. Like I do right. I have my way of doing it. It's hard. All right, I think it's idiotic to we can say in the K, all right, equal to 0 and int j equal to 0 as well. So of course we're going to say if nums I is, come on, what you want to do? If nums I is larger or equal to 0, right, that's where I shall say k equal to I minus 1, j equal to I. Oh. So k, how do I know they have been set? Well, I can do this as minus 1, right? I can do this minus 1. So I can say, is this and, like and actually should be this, right? And j is smaller than 0. We do this. Okay, so we set this. Then we say int res equal to new int. Actually, we just need to do nums.length. Right. Then we do merge sort. So we have k and j. So basically we'll compare the two. We should say while k is larger than 0 and j is smaller than nums.length. Right. If nums k, right, is smaller than nums j, then we say res. Oh, we need a res. And int I equal to 0 as well. So res I equal to nums k and k or minus minus. Else res I will equal to nums j plus plus. I plus plus, right? Then once we're done, we can say while k is large equal to 0, we simply just keep saying res I plus plus equal to nums k minus minus while j smaller than nums dot length res I plus plus. Yeah, I used my middle finger for the plus sign. It's supposed to be my pinky. Hard, very hard. Right, should be my pinky, but doesn't feel right to me. Okay, 26. Yeah, I have to like really, I have to look. Uh, 977. Use merge sort to achieve ON time complexity. I was going to type 33, but I typed. I was so wrong. Yeah, will be a long journey to get the speed back up, because I need to get it right, but it's very hard to get it right. Oh shoot. Oh my damn it. So there might be a case where j is smaller than 1. If j is smaller than 1, what does that mean? That we never meet Alright, I think we should just both start with 0. So I can do this, say j is equal sign, right? Equal to 0, and the sign is this, and k, where's k? K is here. I don't know, man. It's just feels awkward. Yeah, that doesn't work. Well, in this case, they're both landing on the same value, right? They're both landing on the same value. Maybe these are edge cases, we need to consider them separately. So like they are both landing on the same value. And yeah, maybe I shouldn't even consider it. Okay, so I think what I need to do is just and I is smaller than nums dot length. Right, and then here the same thing, and I is smaller than nums dot length. Yeah. Try this one. Nope. So basically, if yeah, how do we generalize this? So if I get out, if j is 0 and k is 0, right? Then we just need to decide. Yeah, that just, if j is 0 and k is 0, which means we haven't had anything. So we're going to say if j is equal to 0 and k is equal to 0. So when that happens, we need to make a decision, right? We need to make a decision, which is either we will do, I can say if nums 0 is smaller than nums.length minus 1, then we just return res and return nums. Otherwise, we will, or you can just set up their value, right? And say if this is larger than or larger equal to. Ooh, larger equal to, is this none decrease? Yeah, it could be equal to. And I guess it's fine if it's larger equal to, and then we just set, what I'm trying to do is set k shall equal to nums.length minus 1, something like that, right? Because the other way will be fine. J will be at the front. So we can probably do something like this. And, there's 3 and here. Right. You can call this is all numbers are negative. Does that work? Nope, because J has issues. Well, in that case, if K is equal to this, then J has to be, yeah, you have to reset J. Then J has to be nums.length. Basically, we don't do J. And the other situation, J will become 0, and K actually need to be, yeah, there's actually a, hold on, I do think this one needs to, we need to work this a little bit. All right, I'm going to say if this, then this, else, say k equals minus 1, j is equal to 0. Something like that. Oh, you have to. My bad. Yeah, you have to. There's no way. There's no way you can do it this way. See the way I'm typing? Like, I move my hand all the way to the right, all the way to the left. I just don't use on the right hand side. Definitely, I don't use my pinky at all, actually. Very, very rarely that I use my pinky. I need to reduce the travels I need to do, right? I need to reduce the travel. A lot of error. Mainly because, okay, is this right? That's actually not right, because my pinky should be on this. Yeah, you're moving too much. You're basically, all right. So the problem, okay, the problem is I'm moving my pinky I'm moving my hands too much. So if I want to type faster, I need to reduce the amount of travel my hands make, right? And to reduce the amount of travel my hands make, I need to use my pinky more. I definitely need to use my pinky more. That's hard to do, man. Very hard to do. Let's take a look what I try. It's a 2-pointer. Ooh, I can directly do this. Oh, 2-pointer to go directly. Ah, I think that's easier than my solution. You don't have to consider this. So 2 pointers are on either side, and whichever is bigger, you put it at the end. Okay, I like this idea. So we're gonna try it again. Actually, we can just keep going and then, right? Well, yank this. Yank this. Okay, so this one will be inspired a 2-pointer solution inspired by the solution from last year, from the previous. No, pinky. Submission. No. N, where's N? N is here. Okay, so yeah, 31, put 41. 3. Oh no, that's not what we want. W. Page down. Okay. Okay, so int I equal to 0, j equal to I might as well do int n equal to nums dot should be this. So that's n minus 1. 1 pinky. No, it's here. No, it's pinky. Pinky is for the semicolon. right? And then we say int res. No, it should be really, really hard to change my habit. Res. While I is smaller. Oh, yeah, smaller than j. Right. If nums int I sqr no squared. Yeah, squared. sqi equal to nums I times nums I squared j shall equal to, where's the equal sign? Equal sign pinky. Nums. Oh, it's completely. I'm completely relearning this pattern. This is really. I'm struggling. All right, I think I'll just don't care. I'll type the way I type because it's too hard to change. But I will, just try to be more familiar with the whole thing. Smaller than sqj. Right, and then we need a int k equal to 0. Right, so if that is the case, then what do? We say, actually that's not, this could be n-1, right? So basically we can say res k minus minus equal to sqj. We also need to move j minus minus as well. We can do else res k minus, always k minus minus, right? It's just sqi I plus plus. So we pick the one that is bigger, we put it in, and then we move forward until the two numbers meet each other. Well, this is smaller than this. I think it should be smaller or equal to. Right, then we can just return this. Okay. Typo. Forgot to initialize it. Yep. Okay, so that's that. Done. All right, I said 30 minutes. It's already 40 minutes. I want to think about this problem a little bit more. I mean, yesterday was a little bit, rush. But honestly, it didn't have a good solution. I mean, what we have found, right, is given a grid, Actually, I'm using this. Right? And then we're gonna start from here. We're gonna start from here, and then we're gonna end at here. And this is a 1, which means the Manhattan distance. Right? Manhattan distance for this is 0. And this is 1, 2, 1, 2. That's 2. Right? And so 1, 2, 3. This is 4. This is 3. And we want to find a path in which the maximum, right? The maximum the minimum on each path, right? The minimum on each path is the safeness factor of this path. I want to find the maximum. So we start from here, so at least it's going to be 2, right? So we can pick a route that's just stay away. I mean, the idea is still like each step you can try to find something that steps away. Maybe is that Dijkstra, right? So like each path you're trying to get as big as possible, right? To get as big as possible. So the first step, if we go Dijkstra, right? The first step, okay, we go here, right? And then the second step, I will check to see if it makes us even. Well, the first step is I have here and here, right? And the second step, because I choose this, is going to be this or this. And now I choose this one. The third step is going to be this or this. But so it's not Dijkstra. It's just every step you pick a bigger one. All right? It's just every step you pick a bigger one. Because it's not like the cost of reaching. Right? It's not the cost of reaching. It is, because along the way you're finding the minimum, right? So the minimum of reaching here is 2, right? The minimum of reaching here is 2, and the minimum of reaching here is 1. So you save those, right? We have the minimum of reaching these places. So the minimum of reaching here is 1. The minimum of reaching here is 2. So we pick the bigger one. So I pick this. And you're here, and I can say the minimum of reaching here, because this is 2, so it's going to be 2. So I put it in. The minimum reaching here is going to be 2, but it's 4, right? Originally is 4. So we don't go. You have to go, right? Like you have to. Or should we like say the maximum of reaching here? The maximum of reaching here from everywhere. The maximum of reaching here among all the paths. So each path I keep track of the factor, right? So everything, yeah, if I reach this place and then I can make it bigger, right? Because what we want is the biggest, right? The biggest. No, what do we want? The maximum safeness factor of all paths. That's what we want. We want all the paths as we go through, and then one of them has the maximum. if I only pick the path that guides me higher, or among the 4, I pick the biggest to go. At each step, I pick the biggest to go. I don't think that will end well. No, that will not end well. Yeah, what we want to find is the maximum from all the paths, right? From all the paths. So if we keep track, right? If we keep track, we can say we want to find a maximum of the path reaching this. If I know the maximum of the path reaching this and then reaching this, then I know, right? The maximum among all the paths that lead to reaching this. Because to reach here, you have to reach this or this, right? And okay, so maybe there is a way to do it that way. That's a 2. 1, 2, not a 3. So I want to find a maximum of reaching this on all the paths, right? So we need to find the maximum reaching this. So we can say, okay, the maximum reaching this is 2, right? Because there's only one path. So the maximum of reaching this, because to reach here, we can go from this, right, to this. Or we can go around. But it will not be, because we are recording the smallest, right? We're recording the smallest. So if along the way we have something bigger, then we'll take this. If I have something smaller, then that's not as good as this, right? So okay, so the maximum of reaching here, right? So this path coming in, maximum reaching here is going to be 1, because this is small, right? This is smaller than this. So we say the maximum reaching here is going to be 1. The maximum of reaching any position, right, is going to be its value, right? The maximum, it's going to be its value. So which means it's not going to be bigger than 2, right? It's not going to be bigger than 2. So it will be something smaller. So for the maximum reaching here, okay, the maximum reaching here by itself is 3, but this path going down is 2. So the maximum reaching here is also 2. Okay. And now we have this one, right? Then we have this one. And the maximum reaching here from this down, the maximum, this down is 1. This on 2, so the maximum reaching here is going to be 2. Oh, we have to handle this one as well. So the maximum reaching here is going to be 0. Right? So this, now maximum reaching this is 0. Maximum reaching this is 2. Maximum reaching this is going to be 2. So now from here, the maximum reaching here is going to be 2. That is also a 2. The maximum reaching here is going to be, this is 0, but this is a 2, so it'll be a 2. So the maximum reaching here is a 2. So I do think a BFS shall work, right? A BFS shall work. 1, 2, 3, 1, 2, 3. BFS shall work. So we have 1 on 1 here, so basically it's 0, 1, 2, 3, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Yeah. Wait, but the Manhattan distance, the minimum Manhattan distance. Okay, so but these are, yeah. Okay, so when you start from here, which is 3, Go here, this is gonna be 2. Go here, it's gonna be 2. All right. Then this go here is gonna be 2. This go here is gonna be 1. This go here is gonna be 1. This go here is gonna be 0. Okay, then this coming down is gonna be 2. And this coming down is gonna be 2. This coming down is gonna be 0. This coming down is 2. That's 2. That's 2. And that's 2. That's 2. That is 2. So the answer is 2. Huh? I do think this one will work. Okay? So yeah, I'll do this tomorrow. Alright, I'll see you guys tomorrow. Adios.